Black holes are most strangest and fascinating object in our universe. It is a great amount of matter packed into a very very small area. They are extremely dense. It has the strongest gravitational field in the entire universe. It curves space-time so much that nothing, not even light, can escape from it. Think of star which is 10 times or 15 times more massive than the sun squeezed into a sphere approximately the diameter of Los Angeles. But what happens if you fall into a black hole? No matter how strong you are, your body would be stretched apart. You're ultimately going to get torn apart by the extreme gravity. But this answer may be not correct. Answer of this question is not as easy as it seems. Because black hole is a place where the laws of physics break down. Here comes the mighty paradox known as black hole information paradox. This is a paradox which resulting from the combination of quantum mechanics and general relativity. Information in our universe is fixed. Our universe cannot create new information and it cannot destroy information. In other words, information is neither created nor destroyed. What is information here? We can use the laws of physics to predict the future behavior of a system, whether it's a particle sitting in a box or a complex chemical reaction or the whole entire universe. Our knowledge of physics allows us to make firm, reliable predictions that take our knowledge from the present into the future, and that same technique allows us to dig into the past. If we know all there is to know about a system, then the same laws of physics that extend into the future also extend into the past. It's this reversibility that allows us to make the leap that information is preserved. If I know everything there is to know about a system, then the laws of physics tell me how all those particles will behave past and future. Thus the raw information of the system. What does actually happen when someone fall into a black hole? That's where reality becomes really strange. The moment you entered a black hole, reality would split you in two or clone you. In one of these realities you would be incinerated, and in the other you would plunge into the black hole and fall through it without being harmed. Imagine you and a friend, you both signed up to go on an adventure to the nearest black hole. One of you will go in and the other will be an observer. Now this is where it gets weird. As you accelerate towards the event horizon, your friend sees you stretch and contort as if they were looking at you through a giant magnifying glass. But as you get closer to the horizon, you appear to move in slow motion. Your one year will become 1 year to your friend. And as you reach the horizon, you remain there motionless, stretched across the surface of the horizon. The heat begins to engulf you. Your friend sees you slowly obliterated by the stretching of space and the ring of fire called Hawking radiation. Before you get a chance to cross over into the darkness of the black hole, you are reduced to ash. Now let's see it from your point of view, because something even stranger happens. From your perspective, you would sail straight into the ominous black hole without so much as a scratch, no slow stretching and no scolding Hawking radiation. You will see the outer space is moving like fast forward. Your 1 minute will become 1 year to your friend. You would live out the rest of your life pretty normally until you reach the singularity. But what's wrong with your friend, and why are they telling everyone that you've been barbecued to a crisp by radiation outside of the horizon, while you're chilling inside the black hole? Actually, you really were burned to a crisp at the horizon and you are inside the black hole at the same time. This is because the laws of nature require that you remain outside the black hole as seen from your friend's perspective. And quantum physics demands that information can never be lost, and all information that accounts for your existence has to remain on the outside of the horizon. How can a black hole clone me? This is called as black hole information paradox, but in reality there's no paradox, because no one ever sees your clone. Your friend only sees one of your reality and you only see yourself. Neither one of you can compare notes and no one really knows what happens.